Let's go ahead and get started again. Folks will be joining in, but this is our 10th session on monitoring and operations. It's one of the last ones in our architecture subtrack, and we'll be moving into product and process management in our next session at the end of March and have an intro to product management. And again, this is not necessarily targeted to product managers, but to technologists that want to understand the discipline of product management. If you do have product managers on your team that have not been formally trained in product management, then this would be a good introduction class for those folks, though. So, as a reminder, we have our YouTube channel, so please subscribe. We're getting those videos posted almost immediately. When I say immediately, within a day or two. So Doug's our colleague who does the hard work of scrubbing and editing out all of the ums and pauses in there, and also privatizes your folks. So you won't hear any names. You might hear your first name, but there won't be any identification of you guys on the call. So don't worry about asking questions in the chat. And then also you can interact with our agent. This is kind of replaces our search engine on our site. Almost everything we cover has blog posts that support it. So just ask the questions if you don't recall, and it'll hit a lot more of our blog posts that cover these topics. So recall this really busy slide. This was the availability risk, and it was the risk of failure. We talked about the probability of an incident, the impact of an incident. Our previous sessions, we covered almost everything on the left side, and we covered a little bit on the right side of this. Just the last piece that we're going to cover on the risk tree is designed to be monitored, focus on time to detect, time to isolate, and even time to resolve. So, and again, all in the context of we're designing for 4 nines. And we talked about 4 nines is only a few hours of downtime a year. So the higher your availability requirements, the better you need to be at monitoring. And we'll explain what we mean by business metric monitoring and system component monitoring in just a bit. And this will be pretty quick. Then we'll spend more time just on operations, which is really around running your engineering organization like a business. So designed to be monitored beyond just basic system metrics of CPU and system health, disk IO. You really need to know how customers are interacting with the site, because you want to identify things before they become a bigger issue. And in looking against prior history, you can detect problems or detect incidents before they become bigger problems. So one of the key concepts is the separation of an incident versus a problem. An incident could come from multiple sources, whether it's identified as a people issue or you're lacking monitoring, but we're really looking for the underlying root cause. What actually impacted the customer or potentially impacted your team? So one of the key concepts there is the Pareto principle, and typically 20% of the problems that are occurring cause 80% of the incidents. So that's very common in your environment. But the key is to really track your incidents and problems separately. So let me pause there by show of hands, and you can just use the raise hand question feature in Zoom. How many of you are tracking problems separate from incidents? That means they're related, perhaps in Jira or some tool, but you manage them as separate but related items. Any show of hands? Yep. I have at least one and a few others. Good. All
We have
right.
3.
Excellent. All right. We'll go into a little more detail of why that is. Now, we understand when you first start out, if you're very early in stage of growth, you might commingle these concepts, but very quickly you're going to want to decouple these and relate them. If you're using Jira or similar tools like Azure DevOps, they will have these capabilities. So remember, a lot of problems can have, or actually incidents can have contributing problems and vice versa. So you'll want to understand that relationship. So why do we monitor? You really want to make sure you're maintaining the functionality of your systems and overall availability. You want to detect, isolate, and restore issues before the customer can. Some cases you can't, but also longer term, you want to prevent reoccurring issues, and that's your root cause problem analysis. So what does it help you do? The monitoring helps you in several aspects. So one is time to detect, TTD. So you identify an issue before it becomes bigger. It also decreases time to restore, and that's the combination, and it makes it easier to identify where there's an issue, and it makes it easier to isolate and correct things. So looking at it from a math perspective, the overall time, the math is time to restore, and that's from the start of the incident all the way until its service is restored. There's some sub-levels of tracking. First is time to detect, which is when did it actually occur and when did you first detect it from your engineering team. Time to isolate is the time from detection until you figured out what was the cause, when you can identify what your workaround is going to be. And then time to correct is getting the full service restoration. So now, by show of hands, how many of you are tracking time to restore in your system? First question. So show of hands, is anyone tracking this? Good. All right, I see two of you, three of you doing that. Now, how many of you are tracking this next level down metrics, time to detect, time to isolate, time to correct, at least one of those as a subcomponent of TTR? Are any of you tracking that? Good. All right. So, Leah, do you mind coming off mute and just kind of sharing how you're tracking that?
We do time to detect. So basically, it's a subset of time to restore, and we just get that time frame. We're hoping to use our alerting more efficiently so we
Mm,
can be quicker at this.
very good. Do you specifically have a field in your problem management solution that identifies this, or is just in the body of the problem itself, in the text of the describing like the timeline of that? Are you able to do like math across a lot of your problems?
It's a field that we have put in Jira. I don't know if I would have to look and see if they've done anything cross product. I know we can look at it within our teams.
Good. At the very least, Jeff, within your teams, if you can see it in within your team, that's very, very helpful. So and that's the level we want to see. One of the challenges you brought up though is consistent usage of a tool like Jira across your teams. So this is where it helps to have some leadership, someone really driving this and making sure you're capturing at least the minimum level of detail. Everybody should be tracking time to restore because that's really needed to calculate your availability and your total downtime for the year. And then your next level of maturity is getting at least one of these, preferably time to detect, and then the next two are optional. If you get one of the others, you can infer the last one. If you just at least have two of the three on the bottom row, that's helpful. So again, your goal though is to try to get to 4 nines. In some cases, you may design for 3 nines, but the point is this is how you get to and operate at 4 nines, is really reducing the impact of an incident, not just the probability, but the impact. All right.
Hey, Philip, I have one thing to add. So
Sure.
if you start to use some incident management tools like OpsGenie, PagerDuty, you get some of these data for free. You can
Yes.
you can manage through Jira and then look at it in depth and try to see how the teams are doing. But if you have to produce an overall number for the execs or external stakeholders, but you can get that through external tools.
Excellent observation and recommendation. Yeah, you just reduce the likelihood that you're not going to capture it. And a tool like OpsGenie, that's a much better solution because that really is measuring downtime at a much more granular level and it's more accurate. So yeah, I think I would trust an OpsGenie output more than a human entered one though. And and we do due diligences all the time, and so we look for situations like that. Eric raised his hand. Is that comment or is that still from a previous one?
No, that we do all three on the bottom. The way we do it is we just assign a scribe and have a really detailed timeline, and then kind of go back and then manually add that to Jira so we can query it and build reports and everything.
Got it. Do you have a tool like OpsGenie that can also capture it though? At least it's measuring downtime.
Yeah, we have PagerDuty, and so that'll be the first entry where we go and get that from PagerDuty when was it called.
Good. Very good. All right. So, one of the goals of reducing time to detect is that most of you have already mentioned this. A lot of this information is already there that you have. And so you're typically detecting initially just system level monitoring, but the next two level of monitors are business KPIs or synthetic transactions, which capture those. So business level metrics are around actual behaviors from the customer perspective, not necessarily is the system up or down, but are there any changes to logins? Are queries taking longer? Are we getting more reports? Are reports taking longer? Are transactions out of band? These are business metric monitors. And then synthetic monitors are tools where you do synthetic transactions to the system, typically to identify if connections are working or not, though. So this is the next level of maturity that will help you with your time to detect if you have business KPI monitoring and or synthetic transactions. So again, by show of hands, how many of you are doing business monitoring, not just system level monitoring, by show of hands? Good. Yep, the same usual suspects. Very good. And then quick show of hands, how many of you doing synthetic transactions? Good. All right. Let's keep rolling. So good. A lot of you are following these best practices. So effective monitoring, again, the idea is identifying something's wrong, but you're trying to identify it before customers are even aware of it. So, and the analogy here is the iceberg, the tip of the iceberg. What's visible is there's a problem, but there's a lot more information needed to gather to identify where the problem is and what is the problem. And so just visualizing that a bit more at the top, the way these triangles are drawn is you're actually going to need typically more information to get all the way through the time to resolve and to find out what was the root cause. So monitoring just helps you identify things early, but you're going to need more information, typically from more systems or more humans, in order to resolve the situation quickly. The more you can integrate these, the faster you can detect and restore more automatically. So, at the second level down, you're trying to identify if you were just using system level, are there actually ports being overloaded? You're trying to identify where the noise to signal ratio is, and also looking at some negative confirmations to identify where the problem is. And then lastly, where you're trying to mimic the problem, this is more like the system level monitoring, the business level monitoring and the synthetic transactions. These are trying to simulate where the problem might be occurring. So analogy that we use is the stock market. So at a high level, think of the Dow is up or down. I'm sure many of you have noticed that this week, and a lot of noise going on. And you start to identify what's really driving that. Is it a particular big buyer like Berkshire Hathaway, or is it one of the larger items on one of the indexes, one of the larger ones? And then what was the news about one or two of those items that caused that? So again, you need more and more information to identify what's actually going on. So again, just thinking of that from a monitoring perspective, you need to triangulate quite a bit of information there. So at the very least, and I think a lot of you are already doing this, have a single dashboard that mimics, if you can, your business level metrics for monitoring. So it's not just looking at all the systems that are any of you having CPU issues or memory issues, but really looking at a business dashboard where you can aggregate these and see, are these within normal bounds or not within those. And so that's actually helpful to have that single dashboard to detect that. And when you see these big network operation centers, the NOCs, they'll have these projected on the wall, and these are constantly running all the time. So this example here is actually trying to show business transactions, and this is a plot of curve over time. And this was actually a case study from some prior work that some of us had at our previous job that we worked at. But this view here shows typical transactions during the day. This is an e-commerce site where you typically see a load early in the day, then another one later. And the expected curve is a typical day, like a typical Monday. And the area under the curve we're showing here is some lost revenue. And so this is the focus of the shape of expected versus actual. So there's a few ways to really see what's going on. What may happen though is you'll get like users will try to do a retry. And so they're actually going to hammer the system a bit more. And then they'll actually depart and leave the system. And then it may take a while before it comes back. So that will look different, though, typically than perhaps what you see at a system level, that you're going to see people retrying and then leaving the site. And so you'll get different ways of seeing degradation over the day. Now, there's two approaches. One is statistical process controls, which is what is expected, out of 1 sigma, 2 sigma, 3 sigma. Another approach, though, is first and second derivatives. And so the idea here is the first one is determine, are we actually changing a typical behavior? The second derivative from calculus is how quickly it's changing outside of those tolerances. So this is typically difficult to do on your own. The tools that you're buying are doing a lot of this for you. So again, the first view here, first and second derivative versus statistical process controls, is looking at what are typically out of bands. And one of the things that was mentioned on this slide, though, is natural changes in your workloads may not work with statistical process controls. So you might need a combination of both of those to identify if those are going on. Now, by show of hands, how many of you are doing this manually today, either first and second derivative testing or SPC? By show of hands, is anybody doing that manually today for their key systems? I'm going to assume no on that. I know Robert still has his hand up, probably from before. And are any of you using tools to do this, or do you know if your monitoring tools are doing this today, or how they're doing it? For those of you doing either OpsGenie or maybe Dynatrace or some other tools, are any of you aware of how you're doing your business metric monitoring and what actually underlying mechanism is being used? Datadog? Yeah, exactly. Yeah. So Dynatrace is doing this under the hood. That's what you're paying for. So this is one of the risks of these tools. They're doing this automatically for you. It's somewhat helpful to understand the underlying algorithm of what's going on as you start tuning your system. But as you can see, it's very hard to do this manually. You need a tool, you have to pay for it, and these tools are not cheap. But most folks that start to use a Datadog or Dynatrace, they really struggle to let go of those tools. They're very effective, and it's very hard in today's day and age to imagine living without that. It's like living without power. So, all right. So if you have all this monitoring, this is helpful just if you have a daily operational review. And so this is the daily service view of items that would typically go on. And some of you may not do this daily. Some of you may do this weekly or monthly. But at the very least, most of you should be thinking of this daily and looking at this. Even if you're delivering new features every day, if you're responsible for your services. So what you're typically looking at are there any complaints coming in? And again, this may happen also by an executive may be doing this. You may have customer complaints, you have executives that are calling in, things that you've manually identified, anything auto-identified from your Dynatraces or your Datadogs, anything predictive, any other trends that you're seeing. Those are all inputs. Outputs would typically be looking at overall, what are the trending that we see? You will probably have a monthly or quarterly operational review. You should be having, making sure you're doing your problem resolution and making sure you're continuing to do root cause analysis and schedule your postmortems. So by show of hands, how many of you are doing this at least weekly, having an operational review? Very good. Are any of you, those three, Leah, Steven, Christopher, are you doing this daily? All right. Nobody's doing this daily. That's all right. Weekly, very good. We typically see daily more in a B2C space when you've got over 1,000 concurrent users, or in a larger B2B space where you've got hundreds of tenants, if not thousands of tenants with tens of thousands of users. So the more users, the more customers, the more likely you're going to increase this frequency and have dedicated teams looking at this potentially all day long. All right. So we've wrapped up monitoring What we're shifting towards now is a concept just called service management. And so this is really running your teams like a business. And these are some common operational processes. A lot of these terms you'll see here come from the world of IT service management. And most of you may not think you're in an IT service management world, but these concepts still apply in running an engineering team. And we're going to walk you through what these are. But to really lead your engineering team, we want to introduce you to these concepts pretty quickly. And we're going to do a pretty quick tour through these. And we're going to walk you through an analogy of owning a bunch of bakeries. This is how I learned this concept when I was at eBay. I was responsible for these systems for our corporate department, and both eBay and PayPal for the actual production sites also had separate instances of this. And so this is a common discipline needed if you're managing tens of thousands of employees and millions of users. We'll walk you through these concepts, and there are tools and mix of tools that help you do this. But it's helpful for you to lead your team to really understand the operations of keeping your systems and services running at 4 nines, 3 nines, and hopefully you don't have anything you need to run at 2 nines. So the analogy we're going to use is you own a chain of bakeries, and we're going to bring up certain scenarios and situations and do the equivalent scenario in a technology organization. So the first one is service ordering, the bakery, the menu. What does each store offer? What does it cost? What's the price list? But you also have things at the bakery that may not be on the price list. You know, a special cake, some catering. These are things that it doesn't matter to put on your standard menu. In the technology world, whether you're software as a service or if you're an IT department, if you're software as a service, these are the features that you deliver or are supporting today. And it's in a way that's easy to understand. So if you're a B2B world, that would be a feature matrix, or potentially you might do that in a B2C world. If you're just a traditional IT department, this is called the service catalog. Your shared services departments may have something like that. What's the price list? Is there any consumption charges? So, for example, if you're a software as a service team and you have to procure infrastructure, whether you have a data center or you have another team that manages your provisioning in AWS or Azure, you'd like to know, what is that price point? What's the price list? Sometimes it's not even shown to you. And then some things are on demand and some are custom. So, for example, a DevOps team may say it's going to cost us this much to spin up an environment or this much time. Or if you have a shared QA team, they may have some estimates for how much it's going to take to set up, for example, a Selenium environment. So this is the idea of what the catalog is, or the menu, from the bakery world or the technology world. Very simple. So let's get into the incident and problem one. We've already walked through an example before, but in the bakery world, an incident is a cookie's burned. And the idea is, did you notice it before someone else saw it? Did someone complain to bring it to you, or did you notice it before it was shipped out? Or was it online? Did somebody wait until they actually got back and decided to put a complaint on Yelp or Google reviews, and then in turn have a much wider impact versus trying to capture it earlier? So in the tech world, we already walked through that. Alerts and monitoring. The goal is to detect an issue before someone can do it. Maybe it's coming in through your customer support team, or did somebody call an executive and blindside you? So that's all incident management. Problem management is trying to understand what caused that. So problem is, a lot of cookies are burned. Why? Well, it was a faulty thermostat on a particular oven. In the technology world, the goal here is to relate incidents to problems and trying to avoid the number of systems, or at least understand how many systems may all be contributing incidents. And what you typically want to avoid is having too many systems managing problems. And so you want to keep that relationship easy to manage. We talked about incidents should relate to problems. And in true problem management, if you can identify your thresholds, do your root cause analysis, do the 5 whys, which is trying to understand the root cause, that's the goal. And you want to make sure you have that visibility and accountability to make sure it never happens again. So making sure you have postmortems, always have postmortems, and make sure someone is accountable for that. All right. Well, another thing we typically relate together is change and release management. Now, most of you have automated CI/CD, some of you don't, but we're going to walk you through an example of a more manual type process. So We're using the example of the faulty thermostat. And the idea here is, when can we change the thermostat? What are the time windows and who's going to make the change? In the tech world, you may have a change advisory board if it's more manual, or this may occur early on in your software development lifecycle in agile planning to identify dependencies, maybe in your quarterly planning cycle, where you're trying to understand when can something be released or something else. The release management is the actual change to production. So in this case, changing the thermostat is we're going to change it tonight when we're cleaning the ovens. Our contractor is going to do it per our service contract, and we're going to document it and make sure it's done. Okay, so they're going to follow consistent steps. In the technology world, this is your release. It's scheduled and scripted. You have automated rollbacks. Most of you should be having today this stuff well scripted. You may have it automated between environments, but at the last step, you may have just click a button and you say, I'm going to release at this point. So just by quick show of hands, do any of you have automatic deployments to production, or is it just you still have to have a human do the final push, click of the button? Is anyone doing continuous deployments? All right, very good. Lee and Leah, can you just kind of weigh in on what allows you to continuously deploy?
Like what tools we use, or
Well, how do you know you can safely deploy without breaking something?
we have bots and testing in place that make sure, and then we have things that are guardrails to make sure they're reviewed appropriately.
Very good. Yeah. And this is something that's, only been enabled in the last 10 years or so. This was very hard to do more than 10 years ago. You had to build a lot of these tools. And now we have so much automation available so that we can do this with reduced risk. In the past, this was very tedious. You'd have to have a change advisory board and you'd have everyone doing outages. You would typically take downtime. And so the more that you can move towards automated rollbacks, switching, web servers so there's no disruption, that's your end goal here. And, the note you'll see on the right is making sure we do automated rollbacks. We covered that last week in our architecture principles, always designed for rollback. All right. Some other topics we'll cover pretty quickly. Asset management. Some of you may or may not have this on your radar, but in this case, extending an analogy, how many thermostats do we have? Do we have the right model? Where are they? Are they close by? Do we need to order one? In the tech world, it's really keeping track of all your hardware, software, and devices. And for a lot of you, you may not even be aware of this because you may have some other team taking care of this for you in your data center or in your cloud provider. And when you start to get a more heterogeneous environment, you may have different tools tracking this. So you may have one set of tools tracking all of the software. You may have another one tracking the hardware, another the networking. You may also have separate tools if you're actually managing your technology department. IT, you may be managing their assets, their laptops, or their developer workstations. But most of you that are that are product facing may only care about your software and devices. So asset management is the tracking at multiple levels of detail of all your software, hardware, and components. All right. SLA management. This is in the bakery world, thinking of there's multiple levels of SLAs. So, how much time do we have to fix the oven, to replace the thermostat? Contractually, if we have a third party that's providing us that service, what is their agreement? And then what happens in the case of non-performance? So if you're a bakery and you've outsourced this responsibility, you're probably going to care a lot about the time that it takes for this contractor to do that. If these are employees, you should still probably think the same way, but a lot of us don't really think that way. But you should have those same performance guarantees. And so a lot of us miss these SLAs. We're thinking through what are our internal SLAs. In the tech world, who is responsible? Do you have different teams providing that? Are you measuring different SLAs by team? Going back to organization design, we like to see fully autonomous, durable teams. We don't like to see dependencies on other teams where, for example, DevOps is another team, infrastructure is another team, because you then have different teams responsible, for example, for SLAs. So the more that the engineering team is responsible for their SLAs, the better, and that they're fully accountable for it. What are the consequences the services are down, and third party versus internal. So in this scenario, think through if you have if your core service is using a third party, let's say it's a payment provider, it's another outsourced thing, you're thinking through, is that system at 4 nines? What happens if that's not at 4 nines? What's my fallback if that other system that I'm relying on does not operate at 4 nines? So you can't just wait and sue later. You need to design into your architecture the dependencies on any third-party systems. So again, this is where we like to see SLAs tracked at a system level, not just at a team level, but really understanding all the components that interact with your services. What are those SLAs? Are they at 4 nines, 3 nines? What nines are those? All right. We talked to the monitoring already. This one's pretty straightforward. In the bakery world, smoke detector, something should have detected a cookie was burnt before. Was there a warning light on the oven? Did you smell it? There's multiple ways of monitoring that could be feeding you information. In the tech world, this is when we get into the concept of unified event management. You're going to have potentially alerts coming from multiple systems. You want to have them in a consolidated view so that you can try to discern the signal from the noise. The security integration here is, does every team member see the tools, the monitoring tools they need to do their job, or something's blocked? Ideally, we like to see all engineering teams be able to see the monitoring of the systems that they support and not just have it restricted to an engineering lead or to somebody in another team. And then again, human versus machines. What patterns are humans detecting versus machines? Now we're assuming that our tools like Datadog and Dynatrace are doing the statistical process controls or the first and second derivative testing. Just keep in mind, the more that you automate, the more that you may not understand what's going on behind the scenes in your monitoring tool. So every now and then, try to understand the monitoring algorithms within your system. All right. Continuity management. We didn't discuss this too much in architecture principles, but just as this is BCPDR. So for the bakery, what happens if the bakery can't open for some reason? Somebody lost the keys, supplier can't supply a critical ingredient, maybe a macro or micro disaster like a local flood in the environment or some economic downturn. In the tech world, this is pretty straightforward. We talked about different options last week, active-active versus active-passive. What's really needed from a failover? Can you switch over? So for example, if you have a third party, how easily can you switch from one to another? And then overall business continuity, what are those scenarios? So a lot of folks are really hard in this after COVID. They really stepped up their game. Also, the cost to move from active passive to active active is going down. It's much easier to design for multiple active sites, as we discussed last week. So continuity management, pretty straightforward, but this is a way to explain it to the more junior members of your team or to business stakeholders. We're just going to hit a few more of these today. So knowledge and content management, this is also common in service management. So in the bakery world, this is the recipe for the cookies. This is all of the recipes for all of the things that you provide and any modifications or tweaks that are unique per environment. Just a quick aside, real story that happened to me at a previous job. I was responsible for creating a system to manage all the recipes for one of the well-known chefs in Napa Valley, and he owned several restaurants around the country, and he was for years I was always trying to get his chefs to use the same recipes, and we finally got them standardized on using the same recipes, but they found that the items didn't taste the same in different locations because the actual machines were different. So baking is very specific. You actually have to take into account all the different components though. So just having that knowledge is consistent and making sure you understand all the aspects of the recipes of your environment. So in the tech world, pretty straightforward. Is there knowledge needed within your team? If you have a customer support team, how much can you support to them? If you have a third-party integrator, how much can you support to them? Providing more self-service and training so that you can offload things off your team. This is where knowledge management helps. It also helps in onboarding. and making sure that if you've got, when you deal with very large technology teams and you've got a large customer success team or customer support team, they're going to have perhaps phone support, they'll have web support, they'll have even humans. And over time, those folks might be using tools like Salesforce or HubSpot or some other support tool. They potentially have different access points or different areas of knowledge and content management. So as you become a larger B2B supplier or B2C supplier, you'll need to think through all of this knowledge and content that's in different silos of information out there. So, and this is always a hot topic, typically within engineering teams, is how much to put in Confluence versus some other tool. So, how many of you are huge fans of Confluence by show of hands? No show of hands, no lovers of Confluence? All right. What's a better Notion? All right. Will Notion become the new Confluence? Or will Notion always be the best solution for your team? Yep. I think that's a great way to do it. Use it, love it. Love is just too strong. Yeah, this always becomes challenging when you do any kind of content management, and just think through the different teams, different tiers. They're all going to need a way to write their content down for their team to do their job, but at some point they'll have to share that knowledge outside their team, either to another team, or in the case of customer facing, you'll need to take a subset of the information and push it closer to other departments within the company. So don't get too wedded to your content management system. Just make sure it's easy to index and search and crawl and shareable as much as possible. So that's the key takeaway here. But don't let there be too many territorial fights over it. Just make sure somebody's writing it down and that it's captured somewhere and not just in someone's noggins. All right, financial management. So if you're going to run your team, you really need to understand the finances of your team and your services or your entire engineering team. So in the bakery world, some of the things that you care about are when are assets coming off the books, bigger things like is there a lease to renew a building, when are contracts coming up with key suppliers. These are other aspects of financial management at the next level down that you'll need. For those of you that have run large engineering teams, there's a lot of similar equivalents here. And one of the challenges that we always see is, do engineering teams understand all of their costs, their cost structures, their cost drivers? Are there any costs that are shared? One of the challenges that we typically see is a DevOps team or an infrastructure team bearing all the responsibility, for example, for an AWS bill or some other bill, and they're responsible for driving down the costs, and then they have to go influence other teams to drive those costs down. And then also making sure, is the cost structure, is it fair or not? And are you measuring consumption properly? One of the things you'll eventually need to be able to explain as a engineering leader is the cost of developers per hour, and compare that to, say, developers in a different part of the world. And so the trap you want to avoid is the cost per input versus the cost per output. So you'll eventually need to understand your internal cost drivers from a hardware, a software, and labor perspective, but you'll want to be able to translate in terms of output, not just raw cost numbers. So you'll need to really make sure you understand for your team your entire cost structure within your teams. And if you manage multiple teams, you want to have as much visibility into all those cost structures, what's fixed, what's variable. And so that way you'll be able to navigate a lot of these discussions and avoid chargebacks, but also be able to show things, what are the cost drivers to influence the right behaviors. All right, we're going to go through this one quickly. This is asset discovery. This is more of a challenge in larger organizations, which is really understanding where are all of my assets that I have, particularly at a subcomponent level, and looking in aggregate, because it helps you with your financial ones, but also helps you in your recovery time to know where your assets are. So in the tech world, is automatically discovering new assets as they come into your environment. So some of you may be tightly controlled. You may not allow your teams to just go provision EC2 or other large compute in your environments, because that can increase the costs. In other cases, you may want to encourage your teams to provision some infrastructure, but you want to automatically detect it and monitor it very quickly so that you can keep track of what's going to be a cost, a potential threat vector, potential security risk, or increase some licensing. So this is asset discovery. I'm not sure that many of you need this level of detail, but you'll typically need to consolidate information from multiple tools and also just track humans as assets too. When you get into these really large organizations, you're tracking humans and machines and human consumption of machines to relate that together. So you may have this tied either into your internal employee identity management system, or perhaps even tied into customers, large tenants, to understand what are my costs per tenants, to identify that. So this is the analogy of asset discovery. And I think the last term we have in our analogy is automation. So in the bakery is just really trying to semi-automate or pre-do some work anywhere in your delivery. So in this case, pre-mix ingredients, having the dough ready to go versus made from scratch, maybe switching from a traditional soft drink machine to one that does the mixing for you, where you click the button. That could drive down the costs. And then also, for example, adding a mobile app and pickup that will reduce the wait times in the front of the bakery. So in the tech world, just anywhere that you can automate your delivery process, from checking out code to pushing to production, orchestration where you need to combine multiple steps together, and then lastly, just being able to visualize these steps and knowing where there's potential bottlenecks. So remember, we talked about automate whenever possible. Oh, I forgot, there is an important one. This is pretty common though for in-service management, which is time tracking. In the bakery world, so you're trying to track the time to repair the oven, order a cookie, fulfill a large order. These are all very different ones, or even time if you want to expand something. In the tech world, you might have timesheets. So by show of hands, how many of you are doing timesheets today? Yep, Christopher. All right. And for those of you that are not doing timesheets, I'm going to put Eric on the spot here. Why do you not do timesheets? And why do you not need to do timesheets? Eric's not on the call. He's multitasking. So
I'm dropping dogs off at the groomer. Sorry.
no worries. No, I was going to answer for you. Go
I
ahead.
use velocity, right, which is more of a I like to always drive the value part of the discussion about the team rather than just cost.
Yep.
And so I think when you get into timesheets, you really are giving the bean counters ammo to just look at raw costs and not look at value produced.
And Manon had put something in the task that's very good. You really don't need timesheets if you're delivering products. And if your engineers are focused on delivering, particularly story points, that's more important than the time that's spent doing that. Because the reason we had timesheets was because it's project-based work, not product-based work. So the more that you do more project-like work, things you haven't done before, that's when timesheets are more important to take into account.
Yeah,
But
and
you're
then
still,
I also like to tie the story points to actual customer outcomes.
yeah,
And so really try and push that. Focus on
exactly.
customer outcome based value rather than just time.
Right. So the key takeaway here is if you have a product delivery team, you shouldn't need timesheets. If you are doing more project work and your teams may be doing that, it may be important to at least track some times in there. So just keep that in mind. Timers, the more that you can have things automatically detect the start and stop, the better. So going back to the ops genie and PagerDuty, the more that it can automatically detect a system is down, the better, versus a human manually entering that time. And versus service requests, if you're doing story points, you don't need to track the timer. You're automatically saying, I closed a 1 story point ticket or a 3 story point ticket, and you only check at the end of the sprint in the sprint review, did I capture that or not? So that's the danger of trying to manually track time, or if you actually need to track time, or if you need to track output. And then tools. So this is where we see a lot of challenges with large organization tools, are trying to compare time tracking versus output across different teams. And so the more that you can avoid timesheets and focus on output, the easier it's going to be of trying to compare across teams to see who takes too long and who is delivering output. So your the main take I want you to have on this is you still are going to need to manually track human time in some scenarios, but you want to minimize that and you want to automate as much as possible and shift away from too much timesheet tracking unless you're going to do true project-based work. So, but at some point, someone's going to ask you where employees spending their time. A CEO will ask the CTO that question, and you want to be able to articulate where are they spending their time and be able to either avoid that conversation or explain it if you ever get in that situation. Which leads us to the difference between projects, products, and programs. And we're going to discuss this in more detail in the next session. But the differences in these are in the bakery world, I'm going to expand a bakery, or I want to test catering from a new bakery, or I want to upgrade all ovens, or acquire or sell a bakery. Those are actually different types of work. So in the example of an expanded bakery that's actually a project because it's actually a simple one because if you've done it multiple times, which means you're pretty sure what the steps are, you're pretty sure what the dependencies are or duration. So that's a simple project, not a hard one. If I want to test catering, you've never done catering before, this is more like a product launch. This is more like test and learn, iterate. This is more of an agile type thing. And so you shouldn't necessarily manage it like a project. It should be more like a launching a new product. If I want to upgrade all my ovens, that is a reoccurring program, which means it's something that's repeatable. You can plan it and schedule it in advance, and you should be able to semi-automate a lot of those steps. And let's say if you're going to do an acquisition or if you're going to sell off a bakery, those are special projects. Those are going to have probably a high cost. You probably need to bring in someone, an outsider. You might need some executives. These are all very different. And so the only reason I bring this up is your team is not always just delivering features and just making cookies. Your team is going to have a mix of these other activities going on. You're going to do an acquisition of a similar product. You're going to potentially need to do a refresh of some part of your architecture, or you'll need to, launch a major new feature. So not all these types of work are the same. And that's why we're going to cover these topics in more detail in the next one. You're not always able to just make cookies. You're going to have to do catering. You're going to have to deal with all these other scenarios as a leader. So one of the things that helps you just manage your team is what's called a configuration management database. And what this really is just tying together all that stuff that we talked about. So if you own a bakery, you need to have the blueprints, all the recipes, and have, where possible, where the linkages are. So in the tech world, how do I relate all of those processes we just talked about to the actual underlying assets that are creating services in your production environment? This is called a CMDB, Configuration Management Database. And so the items here are understanding what particular components support what particular services so that if a particular web server is down, it impacts, for example, search on my website. That's how that's all tied together. And you're pulling all this information together. How many of you have a CMDB today, an actual CMDB, by show of hands? Configuration Management Database, where you can relate the items that you're monitoring to the items that are in your release schedule to your actual dashboards that you report on, to the work your teams are doing. Do any of you have that level of integration today? Or are these just silos of information? Like we know we released a bunch of features, but we don't necessarily know what services they touch or what assets are actually released. All right. Well, I wouldn't expect most of you to have this, but ultimately your team is going to have to manage all those relationships of all those services and all those processes because all those processes change those services in production. So at some point, your team is going to have to make that relationship manually. And when you get into very large, heterogeneous, complex environments, you have to automate this stuff. You just can't have too many humans making too many changes and understand this. The more homogeneous your environment is, fewer different items, the less that you actually need a tool like a CMDB. So the idea is understanding, we call it the term service catalog in the service management world, but it's understanding my services that are running in production for my customers. How do they all relate together to all those different processes because they all touch those. Any of these items can impact one another, and they're typically tied together by, at the lowest level, assets that work together as components that are services in production because you're making changes through your software development lifecycle. You're adding assets, modifying assets, and changing those. And you're going to have incidents and problems against those. You're doing projects against all those. That's the idea of a configuration management database. So I don't want to make this too scary or too big, but at the very least, we'd like to see CTOs have a very basic catalog. And so this is your level of maturity we're going to show you here of where is this information that's stored that ties together what's in production to what your teams are working on. So at the bottom level is it's the noggins of a few experts to where you have a very simple spreadsheet, maybe a single operational dashboard. The next level is a complex spreadsheet, which will give you example, versus you've got monitoring tied tightly into release management to where at the highest level, you have a configuration management database that shows from the pipeline of the time you pull something, you check out code, or maybe even if you pull off a ticket, you know what's actually going to ultimately get touched in production and the potential customers that are going to be impacted by a change that you make. So by show of hands, how many of you are at least a level 4? Any 4s? Very good. We've got 1 4 out there. Is anybody, Stephen, are you at a level 5?
No, I wouldn't. It's not in a CMDB or a central location.
Eric, yes, what would a negative 2 be? Eric's opinion, negative number is not only is someone not doing something, there's people actually willfully preventing you from doing something like this. They're actually sabotaging any efforts to try to get more mature. So I'm assuming that's what his negative question is. So at the very least, we'd like to have you at least have a basic spreadsheet. I call it the system tracker. So the idea here is just whichever your main system is. If you have key modules, you might have domains as typical services. The overall just health. What is your health? Red, yellow, green. From does it keep you up at night or not? Strategic value to the company, high, medium, low, and launch date, annual spend. So you should at least have this for your main system, website for where customers find you, any CRM that either is in the sales funnel or on the support side, maybe your finance systems that's doing accounts receivable, accounts payable, and perhaps any business intelligence. At the very least, if you're a CTO, you should have this written down somewhere or be able to pull this up very quickly. And this is just the system tracker. This can be a spreadsheet. The idea is you should be able to show this and present this to the board, at least at this level of detail, just to know what you're managing. The next level of detail is adding some more attributes, such as the module name, who's the product manager of that system, who's the technology manager on call, what department does it support, what are some key integrations, what other systems does it talk to. For strategic value, what are the key business capabilities? How do they tie to your OKRs? And then from a functional and technical, you could do a SWOT on those strengths, weaknesses, opportunities, same on the technology side. It's just that next level of detail. And then to help you with your cost structure, the total cost, either upfront that you've spent to date, versus what you're spending annually. This can help you articulate where do you think there's technical debt in your system. How many dedicated FTEs do you have today? How many should you have? Are there any missing roles? Are you dependent on third parties? How customized is this versus using commercial off the shelf? So this is the next level system tracker. This can be in a spreadsheet, it could be in a Notion or in Confluence in a table, but typically we see people start this in a spreadsheet. So this will help you if you can track this as a CTO for all of the systems that you're managing, at least have this level of detail. And again, it can be just updated once a quarter, once every 6 months, once a year, but it should help you drive your roadmaps longer term. So we can give you a blank spreadsheet for this if you want. Just email us after this, and I'll try to remind the panelists to see if we can email this to you later or provide you the spreadsheet. So at the very least, this will help you manage your operations by just having a list of your key systems. and just start with these first few columns, and the spreadsheet expands and collapses for you to track this information. And then having the system tracker, this is kind of the anchor for all those processes that we talked about that make changes to those systems. So again, all of these are the processes that touch your systems. All right. So we did a rapid run through of service management and operations today. We can have some follow-on conversations if any of you want to reach out later. But next week we'll get into Agile, Waterfall, and Kanban. And this is just a high-level overview. The reason we'd like you to see it is we find that most teams are doing a mix of these. Even if they're doing Agile Scrum, they're still spending some part of their month or year, sometimes even part of their day doing some Kanban activities and some waterfall activities that they need. And it's just going to be a quick refresher. Most of you know these concepts, but it'll be a quick reminder of the core tenets of all three of those. Again, because we find most teams are doing more than one of these. So, all right. We wrapped up barely in time. For those of you that want to, I'll stay on for a few minutes for questions. But thank you for spending your Fridays with us, and we'll look forward to seeing you in 2 weeks.